Hello musicians, welcome back. This is Bucky Dirtle and I'm doing another video tutorial on rack, on VCV rack. This is an open source modular DAW and we're covering today two modules and several concepts within each of these modules. We're going to be covering VCO 1 and VCO 2, and within those we're going to be talking about the pulse width, the pitch, frequency modulation, frequency adjustments, all kinds of things. So we'll talk about all these things. So let's get started. First of all, VCO 1. Now I have VCO 1 up here on my screen. You can see it right here, VCO 1. Now VCO 1 is part of the fundamentals pack that's in rack, and you can find fundamentals VCO 1. You can see it right here. And we're going to do VCO 2 shortly, but we're going to talk about VCO 1 right now. So in VCO 1 is voltage controlled oscillator. Now an oscillator is something that goes up and down, making a wave. So we have this voltage control oscillator, means that it's an oscillator that we can control with voltage. And we can control it manually as well. I'm going to go over a few of the things that are in here in the voltage control oscillator 1. And then we're going to have a look at how we actually can control it with voltage in a few minutes. But right now, let's get started. First of all, we have, let's make some sound with it. Let me just start that up here. Now you see here in my setup, I have the voltage control oscillator 1, VCO 1 is connected. It's making a sine wave, and the sine wave is connected to the in channel 1 on my mixer right here. And as you probably know, you've seen from my other tutorials, I like to have an oscilloscope open. I like to have a scope open so that we can see what we're actually making. Not only just hear it, but we can see it as well. And you don't really need to see this so much, but down here at the bottom, I have my audio interface. So I'm able to connect to the computer sound. So you can hear this. So I have that down the bottom because that's not really that critical to this lesson today. So let's have a look first at our waves that we can create with the voltage controlled oscillator. We have four types of waves we can create with VCO 1. We have a sine wave, you can see right here, and we have next to it a triangle wave, we have a saw wave, and a square wave. Now let's have a look at four of these waves in our scope over here. I'll just turn up my volume, and you can see a sine wave first of all, nice smooth sine wave, gorgeous. We also have a triangle wave, and you can hear the difference in sound with that. We have a saw wave. We have a saw wave, which is very cool. And we have a square wave. Here we go. Now I'm going to go back to the sine wave, and I'm going to, oh, and by the way, as you just saw, you can connect any of these outputs to, well, your mixer or any other source you want in here, any other module you can connect to use these waves. It's easy as just connecting the connecting a patch cable to each of the waves, each of the outputs. So I want to go back to the sine wave. Now up at the top here we have analog and digital. Now what these do, this switch lets us, if it's in analog mode, it's emulating what an analog sine wave would be like. Digital would produce a purely digital, as exact as possible wave. So it's sort of an emulation mode. It's not so obvious in a sine wave, but let's have a look at something like a sawtooth wave. That's our analog. That's our digital. You see the difference? The analog, it has some, well, it's not perfect, not a perfect sawtooth wave. And let's go to triangle wave and see the difference as well. There's an auditory difference, and there's also the visual difference. This is why we run our scope, so you can see, not just hear, but see the differences. And our square, look at that big difference. And we do pulse width modulation as well. It gets really funky, but we'll talk about that in a minute. Okay, let's go back and turn this down. Okay, so you just saw that what digital analog can do for us. I'm going to leave it on digital just for now. I'll also say this selection over here on the side, hard and soft, I don't see any different. I don't see that it does anything. I could be wrong, and if any of our viewers know what this does, please tell me. See no difference in the oscillator. Hear no difference in the sound. You can see I'm not seeing any difference. No difference. So I'm not sure what that does for us. But you might know, and if you do, let me know. Put it in the comments here. I'd love to know. Okay, that's that. So we've got those two covered. We got analog, digital, hard, soft. And we have all of our 4 waveforms down at the bottom. Now, let's have a look at this big dial at the top, frequency. Okay, let's turn up our volume on our sine wave a little. Frequency. Not hard to describe, is it? So the frequency adjustment is the frequency. It's the pitch. Very low pitch, very high pitch. Piece of cake, nothing to it. So that's our frequency change. And of course that works the same for all of our waves. Works the same. Digital analog is the same as well. Okay, so that's that. That's our frequency. And by the way, you notice I'm able to turn my volume down very quickly. Any of these buttons in here, if you right click on the button, it puts it back to the default. So if I have my volume turned up and I want to go back to 0, right click. All you do is right click and it immediately puts it back to 0. Great little way to get things back to 0 quickly. Okay, that's that. Now, let's keep going. I want to talk next about the sync right here. I'm trying to get this out of the way so you can see sync right here. Now, I'm not going to demonstrate this, but I'm going to tell you what sync does. You'll notice that when we have our waves going, and you can see it on the oscillator, when you have a wave going, you'll notice that it starts right at the beginning, right here. Let me make this frequency a little bigger so you can see. So it starts at a certain spot, goes up and down over the center line, okay, but it starts at a very specific place in time. If you had another oscillator running, it might start right here, it might start right here, it might start anywhere. It might be on the same frequency, but it may start in a different part of the cycle. If you want 2 oscillators to be synced, to be synchronized, so that they start at exactly the same place on the in their cycle, well then that's what you do. You'd connect sync to another oscillator, and that's what that would do. It would synchronize both of the waves, so that's what that does. Okay, next one, FM, frequency modulation. I'm going to start up another piece of hardware. Well, actually, not really hardware, it's software, isn't it? I'm going to start up a low frequency oscillator, LFO, and I'm going to turn this down. I'm going to take out a sine wave and put it into our frequency modulator. Now, what this does, frequency modulator, it modulates the frequency, modulates this, so it automates this. Now, if I actually take this and I bring it over and put it into my oscillator, let me slow my time down here so you can see this. You'll see that this is actually creating a wave. The LFO is creating a sine wave. So what the sine wave will do is it will control the sine wave as it goes up and down through its cycle. It will be controlling this frequency knob right here. So let's take this out of here, put it into FM. Let's turn up some volume. And now you don't hear anything yet, no changes yet, are you? Because we need to adjust this. Our frequency modulation control voltage, FM CV. Now, we said earlier that this is a VCO, not just oscillator, it's a voltage control oscillator. It's because we can control the voltage, we can control this oscillator with control voltages, and the LFO puts out a control voltage, and that's what we're seeing here now. We're seeing the sine wave controlling the frequency modulation. So that's what's happening. We can put it in a different place, so it will oscillate back and forth through the frequency depending on where we are. So it'll go from the center line back and forth across where we are in the frequency range, and we can control the speed of the oscillations with the frequency of the LFO. So what if we make it really slow, make our LFO like a low frequency, very slow through that frequency range. If we make it really high, we get our UFO sound from the 1950s, from the 1940s and 50s, 1949, Roswell, New Mexico. So there you go. You get all kinds of crazy stuff happen when you start to control the frequency of your oscillator with an outside source. Okay, let me turn the volume down on that. So that's that. Now, that was FM, okay, frequency modulation. So we've done sync, we've done FM. Now let's talk about this one, voltage per octave. Now this is something, if you are controlling your, like let's say if you have a keyboard connected or some other device that you wanted to control the pitches, the frequency, as we showed just a second ago, can be controlled by voltage, like from a LFO, but it can be controlled by voltage from like a keyboard where it would have a certain volts or certain fractions of volts would represent certain pitches. So for example, an A would be a certain voltage, and when the VCO would receive that voltage, it would play an A or play whatever note is associated with a certain voltage. So we can plug in a pitch sensitive piece of hardware or software through here, and we can control the pitch that way. So now it'll also work other ways as well. We can do this, but it'll be crazy wide because now we don't have as much control over it as we did, because now this doesn't control it any longer. So you can hear it goes very wide. So anyway, it goes right to the ceiling and way down. So anyway, so let me turn that off again. This is in my use. This is for pitched instruments. Okay, so there you go. That's what this is for. We talked about sync. We talked about frequency modulation. Now we talked about that one, and now let's talk about this one. This is really cool. This is pulse wave, and this is for square waves. This is only present in square waves. Now let's have a look at the oscillator. This is a square wave. Let me change my time. There we go. There's our square wave. There's our square wave. And if I do my pulse width modulation, sorry, you can see as I rotate it, makes some pretty wild sounds. It may be a kind of a sound you might have heard. Been used in many movies over the years. That's pulse width modulation. Pulse width modulation. Okay, so that's pretty cool. That's the knob that we control it with manually. We can also control it with voltage. So if we go over to our sine wave again, and we do that one. Actually, I'm going to try a different color because that gray is hard to see. Oops. So let me move that back. There we go. So now we are going to control the pulse width modulation with the sine wave from the LFO. So let's give that a shot. And once again, there's nothing happening. And it's the same as when we did our frequency modulation controller here, pulse width modulation controller. Let's lower our pitch. You can see, raise it up, it'll max out. Pretty crazy stuff. So you can get some really cool effects with this. So we're controlling the pulse width modulation with the LFO. And it's done through voltage control. And that's why this is called a voltage control oscillator, VCO, because we're able to control the frequency and control we can control the waveform as well. We can control the waveform as well with through voltage control. Now, I'm saying we can control the waveform. That's what our next little piece is about. Let me take the LFO out of here. We don't need this anymore, so I'll delete that guy. And let's move our VCO1 over there. I'm going to disconnect it. Let's add in our VCO2 because we're actually given two VCOs, two voltage control oscillators. Voltage control 1 and voltage control 2. Now I wanted to bring these up here side by side so you can compare. Let's see what we have. We have frequency and we have frequency. And we have analog digital. Yep, we have hard and soft, which we don't know what that does, but anyway, hard and soft is there. Wave. Frequency. Here we go. Look, the frequency modulation, control voltage. The same as over here. We don't have a pulse width. We don't have a pulse width modulation section, but we do have something down here a little different. We have FM, we have sync, and we have wave. And out. Okay, let's have a look. Let's plug this in and see what this baby does for us. Oh, we have a sound. Now look at this wave. I'm going to go on digital. That's a strange looking wave. Let's change the wave shape. Triangle, sine wave. Look at that. We can change the wave gradually as we rotate the wave dial. So we can go not just to like a sine wave, like if we look at over on our VCO1, we can have a sine wave, or we can have a triangle wave, or we can have a saw wave. Well, in VCO2, we can have an infinite number in between those as well. Like, we can go like a morphed wave partway through a saw into a square. It's pretty cool stuff. And of course, it's voltage controlled. So if I wanted to, I'm going to move this guy over a little further. I'm going to get rid of this guy, so we don't need this guy now. I'm going to bring up an LFO again. If we take our LFO, take a sine wave, and we plug it into wave, now guess what's going to happen? It's going to control this wave adjustment with the LFO. Let's turn it up and see what happens. Look at that, it's changing. Let's go the other way. Now we're going as fast, see. And let's go. We can put ourselves where we want it to be in the waveform change. And you can fine-tune this. You can fine-tune this to be exactly what you want. So there you go. I'm going to turn that one off. So you can fine-tune the way this is controlling it. Okay, so let's just do a little review. Let's do some review. I'm going to get rid of that guy. Put this guy over here. Let's bring back a VCO1. Now, what we learned today that there are two voltage control oscillators, or VCOs, in rack. Voltage control oscillator 1, VCO1. We can change the analog digital. We can change the analog digital setting so that as we remember that the analog is emulating an analog reproduction of what the sound would have been like on an analog device, and digital is a pure form of the wave, or a purer form of the wave. We also learned that we can control the control the frequency with this big knob. We can fine-tune the frequency. Just like in a lot of these things, we have a fine-tune knob where this will change the frequency quite a bit. This one will just fine-tune it. Sorry for not mentioning that. We can control, we have a sine wave, triangle wave, saw wave, and square wave. All can be outputted. When we do a square wave, we also have pulse width modulation, which we can change here, which changes the shape of the wave. We can bring in from another device, like an LFO, we can bring in a frequency, whoopsie daisy. We can bring in frequency modulation and control it using another device like an LFO. And then we would control the amount of that with this one. We can control our pulse width modulation with something like an LFO, and we can control the amount of that with this knob here. We can synchronize this with other things, with other VCOs and other devices. We can synchronize with this. It's like it will start when it needs to start. So this is a synchronization tool for a waveform, as we saw in the scope. What else we got here in this one? We got all the waves. Okay, now VCO2. the difference in VCO2 and VCO1 is it's missing a few options, but it also has the ability to go through the waves. So we can go from sine wave, triangle wave, saw, square. So we can do that. We can go right through it. And we can also control that with a voltage controlled, through voltage control. So with a low frequency oscillator, an LFO, or some other device. So there you go. VCO1, VCO2. Well, I hope you enjoyed this. This is one tutorial of many on rack. So if you enjoyed this tutorial, be sure to check out other tutorials on rack. Also, we have other tutorials on other open source applications in here. Check those out too. And be sure to visit the developer's website. This is an open source application, so it's free for everyone to use. But we need to support the developers, so be sure to go and go to the site and make a donation or show your support in some way. Okay, thank you very much for watching, and good luck with your music, and I will see you next time.